Hi everyone, it's Sorkin. Today we have a problem when we are given end-to-end matrix and we can do the following operation to the matrix. So we can take the any adjacent two elements and multiply that 2 minus 1. So for example, in this case, we have 1 minus 1 minus 1 and 1, right? So we can take any two elements and multiply to minus 1 and we are going to get a new matrix. And also, we need to, our goal is to maximize the summation of the matrix elements. So for example, we can do that any number of times, right? We can do that operation any number of times. So for example, we are doing it here twice. First, we are multiplying these two elements. Now we get the 1 and 1 and the minus 1 minus 1. And we are then multiplying these two minus 1 and we are getting the element, we are getting our sum is 4, the maximum sum. Okay, let's take a look at this example. The approach that we are going to use here is a greedy approach. So we are going to use a greedy approach. So let's take this example, right? So what is the maximum sum that we can get from this matrix? So by requirement, we can multiply, right? That operation of multiplying two cells to minus 1 is to adjacent cells to minus 1. We can do that number of times, any number of times, right? Let's say that we choose first multiply these two, right? These two to minus 1, it becomes plus 5. This one becomes minus 4. And now we are multiplying these two, so it becomes plus 7, plus 4 and the plus 7, right? And we are just getting the sum of all the sum of the matrix. So what's that mean? It means that if there are two, right, it doesn't matter in which location. So they can be here minus 7 and minus 6, right? So we can, for example, multiply these two elements, then multiply these two elements, multiply these two elements, and finally multiply these two elements and get all them positive. So it means that if we have even number of, right, if we have even number of elements, right, then in that case we can just take the sum of our matrix, right? We can just summarize our matrix. So what we are doing here, we are going over our matrix and we are counting the number of negative elements, right? Or negative elements. So we are counting the number of negative elements. If the number of negative elements, right, if they are even, what we are doing in that case, we are just summarize, they're taking the absolute value of each element and returning the sum of the all elements, because it doesn't matter in which locations, right, they are located. Our minus, so because we can do minus, multiplying to minus 1, we can do number of times, right? So we can always make that positive. We can always make these two elements positive. So we are returning the sum of our matrix. But what in case if it's not even? Let's say that if it's odd, right? If it's odd, what we are doing in that case? So basically what we can do, we need to maximize our we need to maximize our sum, right? So what we can do in that case, we can find the element that is the minimum element. So for example, in this case is 2, right? Because it doesn't matter, like we can, for example, let's say that we have one more minus here. Let's say we have one more negative element here. Let's say one more negative element. So we have, for example, let's say we have minus 7, minus 6, and we have minus 5, right? So we can, again, we can make all these elements positive, but during that process, one of the element, we will have one negative element, right? Doesn't matter how many times we multiply. At the end, we are going to have one negative element. That negative element, in our case, if we want to make our sum maximum, so we are taking the minimum element, right? So in our case, the minimum element doesn't matter the absolute minimum element. So regardless of is it positive or negative, if it is, meaning like that we are taking the absolute value of 5, absolute value of 7, absolute value of all elements. In that case, the minimum element is 2, right? So what we are doing in that case, if we are going over our array, the first step, right? We are counting the negative elements. If the negative elements are even, then in that case we are just returning sum of the all values, absolute values, right? If it's odd, in that case we are choosing the negative element. As we go over our matrix, we are maintaining our negative element, our minimum element, and we are subtracting that element. We are subtracting the value of that element from our total sum, and that's how we are getting the maximum sum in this case. Okay, first thing to do, let's create an, actually let's make it long, because our total sum can be over the range of the integer. So let's call it total sum, right? Total sum. Let's for now set that to 0. Also, we need to maintain the negative sum, right? How many negative numbers we have? Negative numbers, actually, negative numbers. And let's also set that to 0. And also we need to a minimum number, right? Minimum number by absolute value in our two-dimensional array, in our matrix. So minimum number, let's for now set that to integer max value, right? Max value. Okay, now we can go over our array, our two-dimensional array, over our matrix, and add the total sum and also count the negative numbers. So let's do that. So int x is equals to 0, x is less than matrix length, and also x plus plus, it's our x-axis, and also we need to do exactly the same for our y-axis. Let's just copy paste that here. So y-axis and y and 0 here, right? 0 and y. Okay, so what we do first? First, let's check that if our matrix, if our x and y, right? If at that position, if the value at the position, if it is less than 0, if it's negative, if it's less than or equal to 0, then in that case what we do, we are going to increment our negative numbers, right? Negative numbers, we are going to increment the value. Okay, and also we are going to add that to our total sum, but we are going to add that by the absolute value, right? Because it might be also negative. So absolute value of, we are taking the absolute value of matrix x and y. So we are taking that element and taking the absolute value of it. And the next one is we also need to update our minimum number. So minimum number, in our case, we are going to take the math minimum of our minimum number, and by absolute value, math absolute value of our matrix x and y. Okay, so after doing that, after exiting this loop, we have a total sum, and what we need to do, we need to first check the negative numbers, right? Negative numbers. We need to check that whether it's even or not. So we are taking the modulo of 2, right? Modulo of 2. If that equals to 0, it means that it's even. In that case, we are just returning our total sum. If it's not, it means that we have odd number of the negative numbers. So in that case, we need to subtract the minimum number from our total sum, right? So we are returning our total sum minus our minimum number multiplied by 2. Why multiplied by 2? Let's say that we have added that number, right? We have to subtract that number, and also we have to let's say that we have our minimum number is -2, but we added already 2 to our total sum. We have to subtract the 2, and we have to subtract one more time because it's because of the negative -2. All right, let's run it. Numbers. All right, great. It works as expected. Let's calculate our time and space complexity. What's our time complexity? Time complexity is of our rows multiplied by our column. So size of our rows multiplied by size of our column. And how about the space complexity? Space complexity is we don't use any space here, so it's constant. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.